Hello, my name is Rich Howard, owner of Architectural Builders Supply, and this video is to bring you a closer look at the Rixson number 370 center hung door pivot. So this video will begin with a tour of the different components that make up this Rixson 370, and let's start at the bottom here. First of all, you've got your bottom pivot, and this pivot is going to be shown to you in the 652 or satin chrome finish, 626 finish, satin chrome. This is the floor portion. This is the base portion of the door installation. Okay. And by the way, this is a pivot rated for 500 pounds. Okay. Let's go over the dimensional properties of each of the parts as we ascend up the door. So the width of the base portion is 1 3/4 inches. The length of it is 4 inches. The material thickness is just heavy on 1/4 inch. And what you've got here is the spindle. We'll go over that more in a moment. Now, the door portion, the bottom arm is here. That attaches like that. Bearing packet inside of there. It's going to allow very nice rotation, very smooth rotation. People who buy this material are, well, obviously hanging a door that's up to 500 pounds, but more specifically, entrance doors to homes, high-end residential situations where you've got excessively wide or tall doors. The Rixson 370 is very common for that application. Additionally, you'll have people that are doing a bookcase that is actually a door, or a hidden room behind a bookcase. The Rixson 370 is very commonly used for that as well. The Rixson 370 stands in the middle ground between the much lighter duty 128-3/4 center hung pivot and then the higher pivots, the 117 and the H117 pivot that will get you, pushing 1,000-pound capacity. So this pivot stands right in the middle of all those situations. Now the dimensions of the bottom arm, the length of it, 7 inch, 1.25 inch. Material thickness, 1/4 inch as well. Going up from there, we're going to still be in the door, and we're going to have the top pivot arm, and this is the part that mortises to the top of the door. Let's go over that dimensionally. We're going to go over the template, which will show everything as well. About 5 13/16, 1.25 inch. Again by 1/4 inch, a little bit heavy on that. Here's the frame portion. This is the portion that gets mounted up into the header. You can see I'm retracting that pin up, and we'll go over that. We'll go over that more in a minute. This is the part that gets mortised up into the header. Walking beam type pivot. We'll talk about that more in a moment. Length, that's 6 13/16. Again, 1.25 inch. Then again, 1/4 inch. Substantial material, as you can see. You'll have a finish plate for that portion we just looked at. Again, this is the satin chrome finish. It's going to look like this when it's installed. So when you open the door and look up, you'll be able to see that finished portion. And that's, other than the floor portion, that's the only finished part on this door. Okay, everything else is unfinished because you would never see it. You're going to get, obviously, screws and anchors for everything. Okay, now, first of all, there's a link below this video to the template. It's called installation instructions is what it is, and we're going to go over that next. Before we go over that, and we're going to start on the template side of that document first. Center hung pivots means versus offset pivots. Center hung means that the axis of pivoting, the vertical axis of pivoting, is in the center of the door. Not in the width, but centered in the thickness, generally, is what that means. The pivot point can be further off the edge of the door from the template in some instances. Reach out to us if you want to discuss that. Some clients will say, can I install it 6 inches over? Then we talk about the rest of the physical attributes of the door, its weight, its height, its width. Some people will even say, can I put it in the center of the door and make my door like a revolving door? Things of that nature. And it's all been done before, which is, again, a reason why someone would use a 370. They might have a unusual width or height or weight of the door that is not really 500 pounds, but they rely on the 370 because it's engineered for that sort of weight. Center hung axis of pivoting is in the center of the door. 1 3/4 door, that means it's going to be 7/8 in, versus offset. That means the vertical axis of pivoting on an offset door, if it's a 3/4 inch offset or 1.5 inch offset, that's measured from the face of the door out, and then the vertical line, the imaginary vertical line axis of pivoting. Okay, now installation instructions. We are on that technical drawing. You can see on the left-hand side you're going to have a technical drawing of all your parts, but starting with the base part. And then as you work your way from the top center down, you'll have dimensional properties of everything. That's important to have because at some point you're going to have to machine the door for the hardware. And it's exclusively the realm of this side of the document that's going to give you all of that information. And it doesn't seem sometimes that it's quite straightforward, but trust me, after you've reviewed, if this is your first time, after you've reviewed it and absorbed it, you'll see that all the information that you actually need is indeed on this page. If you have any questions on any aspect of machining for this or installing it, please feel free to reach out to us. The crucial thing to know is what is the dimension from the jamb to the center of the axis of pivoting, and that is 2 inch per the template. It's called out right there at the end of my finger. Okay, that's assuming that you're going to have an 1/8 of an inch margin between the edge of the door and the jamb. Okay. Then going up through the rest of the template, it will give you all the other dimensional properties of everything as it relates to the hardware. And you are simply going to mortise, assuming it's a wood door or a wood book cabinet, that is exactly what you're going to end up mortising it to. So, for instance, your template for the bottom arm is, well, it's less than, it's 7 inch by 1 1/4 as we called out. Now, if you're going to do the bottom of the door first, that's where we'll start in this video. Bottom of the door, there's a note on the right-hand side that says, coordinate the door mortise depth with the required clearance. So, what that means is this. How deep you mortise the bottom arm into the bottom of the door is directly related to the amount of undercut that you're going to achieve from the bottom of the door to the sill. You can go from a 5/16 minimum undercut to 1 1/8 inch. Okay? So what they're saying is, if you have a 5/16 undercut, you're going to mortise this, the bottom of the door, 7 inch by 1 1/4 and then 1 1/8 deep. 5/16 equals 1 1/8. That's crucial to remember that. If you're going to go down to the maximum clearance of 3/4 inch, then your mortise depth is going to be 11/16. So 3/4 inch undercut equals 11/16. From 5/16 to 3/4, from 1 1/8 to 11/16, you can draw a relationship to arrive at exactly how deep you need to mortise the bottom of the door. It will certainly be between somewhere from 1 1/8 depth to 3/4 inch. That's it. Okay. So if it's going to be, let's just, for an example, if it's going to be, well, easy, would be 7/16. That means your mortise depth would be 1 inch. If you're going to go to 1/2 inch, your mortise depth would be 15/16. If your clearance is going to be 5/8 of an inch, you can see that you're going to get down to 3/4 inch, 7/8 of an inch mortise depth, and etc. You draw that relationship between the two. Generally, however, what you'll start with is prepping at the top of the door. Not necessarily, but you can. Or you can start at the bottom. But the crucial point is this. There's a note here that says on the instruction side that using a plumb bob is crucial because they're giving you 2-inch dimension from the jamb to the vertical axis of pivoting. And that dimension must be the same up at the top, meaning that where your top pin comes down from the door needs to be exactly plumb with where this is going to end up. Now that's crucial to make sure that that's going to end up being the case. So now you've got your mortise depth, then at that point you're going to probably prep the top of the door for the top plate, making sure that your vertical axis of pivoting is compatible. Okay? And then your header is going to get the walking beam portion. I've had people try to install this down to, or mortise this into a header, or it's just drywall. No wood at all. Why doesn't it work? I don't want any wood at the header, I just want drywall. It's not going to work. Quite frankly, I've heard it so many times that I don't want to hear it. There needs to be wood up at the header, substantial wood, in order to get this piece of hardware installed up into the header. Okay. This is going to do the job of keeping that door up in the space. While it's true the bottom pivot is going to, and Mother Earth, of course, is going to carry all the weight of everything, which is really part of the genius of a pivot. That the earth, the ground, the floor is really what's carrying everything. Okay, that's why you can accomplish such really high values in terms of a door weight. But up here, you've got to have wood to mortise this to. Okay. Now the way that I've got this shown is with the top pin retracted all the way in, and we'll go over that more in a moment. You've got the dimensions here. The length, the width, the depth to mortise it is also shown. 1 7/16 will be the total depth for that sort of pocket. And you can gauge from what you're doing in terms of the width, how far that, or how wide that channel needs to be for the body of the operational part of the pivot. You've got your plate, which is your 1/4 inch, it is called out. And then your length and your width. The body needs to be less. And you want to be sure that you're accomplishing that because you've got 2 holes here for the screws, 1 hole here for the screw, so you're going to want to make sure that you're not mortising all of that out. You need to be just shy of those screw holes. Okay. Now, important notes in the upper right-hand corner of the installation instruction. It is the door and frame manufacturer's responsibility to check the hardware schedule and prepare doors and frames. Understood. That's what we're doing now. Pivots drilled for 1/4 20 5/8 flathead machine screws, or number 14 by 1.5 inch flathead wood screws, meaning that your hardware is going to come ready to be screwed to a metal door or a wood door, and it will include those fasteners, machine screws and wood screws. Step number 3, suitable reinforcing by others. That means the door and frame must be properly manufactured to receive this hardware, meaning that there's ample steel there to be drilled and tapped so that the hardware can be screwed to it, ample wood there so that you can mortise it and still achieve a sound installation. Now step 4 is really the part that requires more conversation than less. And it says, for 1 3/4 to 2.5 inch doors, for 1 3/4 to 2.5 inch thickness on the doors, radius on heel edge of door, 1 7/8 max. Here's what that means. The door on the pivot side or the heel side needs to be radiused, needs to be rounded over, so that it, in effect, goes from looking like this to that. You have to have ample clearance for the door to work. If the palm of my hand is the jamb and my fist is a square edge door, you can see as it rotates, the outside of my fist is going to hit the jamb. So what you've got to do is radius that over. 1 7/8 is the maximum radius on a bit to use for rounding that over. So the way that is radiused is the way that I've done it. If you're not using a CNC machine, you're going to use a large router, like a 2-horse router, something substantial, and into that you're going to need to install a really big round over bit, something that has something bigger than no greater a radius of 1 7/8. So if your radius is 1 7/8, or let's just say 1 3/4 radius, because you can't go larger than 1 7/8, that means that you've got a round over bit that's 3.5 inch, and that's huge. But the fact of the matter is you need to put that sort of heel on the door itself, that radiused edge. Think of the top row of tile in a bathroom. That's a bullnose. If you bullnose both sides of a door, that's become radiused. And you need to have a radius on the door so that you can accomplish that 1/8 of an inch. So what I would do is I would lay that door flat on my workspace. I would take my router with the very large round over bit in it, with the base in the router that's been modified just for that bit to fit it in there. And I'd start at the top of the door and very carefully go down the door, very straight, very flat. I'd make it one pass, and then I would do one more pass just in case. I'd be careful not to tip it at all or to exit and push it off the door like that when I'm finishing it, and no more than that. And make sure I get a nice clean radius. Now, one problem with doing that, however, in the realm of veneered architectural wood doors is as you cut through the edge of that door, you will expose or accentuate the different layers in the veneer that makes up a door skin. Door skin is generally 2-ply or 3-ply. You can get a 5-ply door or a 7-ply door. In essence, the material that's slapped onto the core, that's put onto the core of an architectural flush wood door, is plywood, 1/8 of an inch, whatever the case might be. But here's the problem. If you have a walnut door or a cherry door and you radius that over, you're going to accentuate the crossbanding and the backer, so you're going to see these lines. So keep that in mind if you've got a wood door like that. It is an issue that does need to be considered. You might have a job of 15 cherry doors, and they're all hung on pivots because the client wants all the hardware concealed, and you're going to round them all over, not only on the heel side or the pivot side, but the opposite side as well, so that you can achieve that real tight margin, 1/8 of an inch. Well, when you do your round over, you're going to have to think about how you're going to go about accommodating, accentuating the different layers of the plywood. You might, be a woodwork shop and you're going to put no black line or 3 mil or very thin veneer over everything and make all that work, and that works perfectly. But keep that in mind. You might have that to contend with. If you have any questions on how to radius the door style over, feel free to reach out to us. I've done it countless times and would love to hear how you do it or help you determine how to go about doing it. Now, flipping the page over to the installation instruction side. First of all, number one, locate pivot set. Measure 2 inch out from the door jamb on center line of the door. The spindle center must be located at this point. So, sure, that is 2 inch. I've had people kick it in 6 inch. I've had people kick it all the way to the center. The manufacturer has guidelines in terms of where that is located. Then there are people who hack the hardware and hack the doors, and it works for them. So I'd love to discuss that with you should that come up. Step B in number 1 is round heel edge and prepare door for 1/8 of an inch minimum clearance through the opening. That's the rounding over of the door styles. You don't have to do it on the opposite side. Quite frankly, you don't have to do it on the hinge side either. You're just going to need to allow yourself, for sure, a 1/4 inch margin so that your door can clear. That, which of course is related to the door thickness. Step 2, install pivot set. Note, care must be exercised to see that bottom pivot is level. That is true. 370 bottom pivot floor portion. Locate the floor portion and then anchor it securely to the floor. It's possible you're going to have concrete, and what's really awesome about Rixson is they give you some fantastic anchors. Those lead expansion shields are literally second to none when it comes to securely anchoring something. And then you've even got those really long wood screws that are there as well. It needs to be level, and it needs to be accurately located. That's crucial. The door needs to be in the closed position, and when it's closed, it can't creep open or want to creep closed because the door is not plumb or it's towed in or out. That needs to be accurate. I like starting at the top because I can drop my plumb line and make sure that everything is in line before I do my final installation. Step 3, install top pivot and pivot arm. Install door portion of pivot in the door per the template. That's this portion here. Install the jamb portion of the top pivot into the frame per the template. That's this portion here. Center line of pivot should align with center line of bottom spindle. Use a plumb line to assure accuracy. Step D in number 3, mortise bottom of door to receive the arm. Mortise varies with required clearance. We talked about that. Number 4, hang the arm. All your parts are attached. Take the door and stick it. Get it placed onto the bottom pivot. Bring it up into the top portion, which is going to look like this. With the door open, you'll be able to access that slotted screw. And as you turn that clockwise, you can see what happens. It starts to drop that pivot down. You'll be able to drop that pivot all the way down so that the screw is flush and the pin is all the way extended. Now, then at that point, you'll of course be able to attach your finish plate right to where it goes. So it'll look just like that. Now, of course, all major architectural finishes are available in this hardware. Hang door, set the arm, mortise and door on pivot spindle and engage the top pivot pin by turning the pin retracting screw clockwise. We just did that. Dismount the door if required. Open the door with enough to disengage the top pivot. Okay? Should you need to. There's a handing chart here and then a diagram emphasizing the importance of that line being plumb. There are some options available with the 370. You can get a longer top pin. Longer top pin is going to be very typically used where, here's where you use it. California code requires a longer top pin for an earthquake. Should there be an earthquake and that frame that's a rectangle is no longer a rectangle, they want to make sure there's enough metal in the top of that door to keep the door from falling out. That's a good reason for that. Now, also on your bottom portion, you can get a longer spindle. Imagine if you had an excessively long or high undercut, because you were then going to come in with 3/4 inch wood. You'd need a longer bottom stud on here to reach up to the door, okay, so that you can accomplish that. You might have a terrazzo floor, some sort of custom flooring condition that requires this to be longer. You can get that in 1/2 inch longer, 1 inch, 1.5 inch, 2 inch longer. Top pin, 1/4 inch, 1/2 inch, 3/4 inch extended. Security screws are available as well, torque screws. That would be an application by which you expected vandalism, I suppose, and needed those not to come out. And then the other attribute is select finish. All the chromes, the brasses, the bronzes, nickel as well. Okay, stainless material can be done. The Rixson 370 is the workhorse of their center hung pivot line. It is the ubiquitous pivot. It is the go-to for a lot of applications. The only time you wouldn't use it is if you had a 110-pound door. It would be overkill. You'd go with the 128 3/4. The other time you would not use it is if you had an excessively heavy door, something that was going to be iron and wood and glass, or something that was perhaps lead-lined. You would certainly need to use a completely different pivot set if you had a lead-lined door as well. The name Rixson is synonymous with pivots. It's synonymous with floor closers, with overhead stops, with electromagnetic door holders. I'm partial to Rixson because of the uniqueness of their product line. I'm partial to them because of the excellence of their customer service in terms of their technical support. I have a contact there who has answered flawlessly for years every question that I've asked, even questions that I've asked multiple times. And it's for those reasons that I'm partial to Rixson. If you have any questions on the Rixson 370 center hung pivot or any other Rixson product, I do hope that you will reach out to us and discuss. Thank you.